Okay, we're going to look at systems of inequalities. We already know that if we have less than or greater than, that we have a dashed line. And we know that if we have less than or equal to or greater than or equal to, we have a solid line. Another thing we already know is when we use our test points, when we pick a point to test, we know that if it's true, we're going to shade on that side that the test point is on, or if it's false, we're going to shade on the other side, or the side that the test point is not on. Okay, so now that we have systems of equations, we are going to shade the overlapping region. Instead of shading the whole thing like we did before, we are only shading the overlapping region. Okay? So that is the only region we are shading. So let's go ahead and look at our first example. We have y is less than negative 3x minus 2. So let's go ahead and graph that one first. So we have less than, so our less than right here tells us that we are going to have a dashed line. We can see that this is a line that is already in slope intercept form. Okay. So let's see where our line is going to start out at. What is our y-intercept? We have y equals mx plus b. b is our y-intercept, so our y-intercept is negative 2. So we're going to start at the point 0, negative 2. Okay, so we have y equals mx plus b. Our slope is m, so our slope would be negative 3. Okay, so let's go ahead and graph that line. So we said we're starting at 0, negative 2. So we're not going left or right any, but we are going down 2. So our y-intercept is 0, negative 2. And our slope is negative 3. So if we have a negative slope, our line is going to be going up and to the left. So we are going up 3, over 1 to the left. Okay, so let's go ahead and draw our line. And we know that this is a dashed line. Okay, so there's our line. And let's go ahead and pick our test point. Let's go ahead and pick, what about 1, 1? Okay, so there's our test point 1, 1. It is not on the line. So let's go ahead and plug it in. We have y, which is 1, is less than negative 3. Our x is 1, minus 2. So we have 1 is less than negative 3 times 1, so negative 3 minus 2. 1 is less than negative 3 minus 2, so negative 5. 1 is not less than negative 5, so this is false. So if it is false, we are going to shade on the side that the test point is not on. So we will be shading on this side of the line, away from our test point. Okay, so let's look at our other equation. So we have 3x plus 2y is greater than or equal to negative 8. Okay, so the first thing we can see is that this is going to be solid because it is greater than or equal to. So we can also see that this is a line that is in standard form, so we are going to use the cover-up method. Okay, so let's go ahead and cover up our y. So we have 3x equals negative 8. We're going to divide by 3 on both sides, and we will get x equals negative 8 thirds. So if we write that as an order pair, be negative 8 thirds, 0. Okay, so there's our first point. Negative 8 thirds is negative 2 and 2 thirds. So let's go ahead and plot that. So it's between negative 2 and negative 3, but not quite negative 3. So we have negative 8 thirds, 0. So let's cover up our x. We have 2x equals negative 8. Or 2y, excuse me, equals negative 8. Okay, so we're going to divide both sides by 2. So we're going to get y equals negative 4. If we write that as an order pair, we're going to get 0, negative 4. So let's go ahead and plot that point. So we're going left or right, 0, but we are going down 4. So 0, negative 4. So let's go ahead and make our line. And we said this was going to be a solid line. Okay, there's our line. So now let's go ahead and pick a test point. Okay, so we want a point that is not on our line. So let's go ahead and pick, actually, why don't we just pick 0, 0? That'll make it easier. So let's pick our test point, 0, 0. So let's go ahead and plug it in. We have 3x, so 3 times 0, plus 2y, which is 2 times 0, is greater than or equal to negative 8. We have 3 times 0 is 0, plus 2 times 0 is 0, so we're left with 0 is greater than or equal to negative 8, and that is true. So, since it's true, we are going to shade on this side of the test point. So we are going to shade on this side of our line. Okay, so here's where the overlapping region comes into play. So our overlapping region, on this line, we're shading everything on this side of the line. But on this line, we want to shade on this side. Our overlapping region would be this piece right here. That is the side that they are both going to be shaded on. So our overlapping region of both lines. Okay? So, the entire shaded region is the solution to the system of inequalities. Okay, so this whole shaded region right here is the solutions to the system of inequalities. Okay, so I'll ask you guys a question. Is the order pair, I'm going to use 2, 2 since I already put it on there, a solution to the system of inequalities? Okay, so we're looking at 2, 2, so this point right here. Okay, so we said that this shaded region right here was a solution to the system of inequalities. Is the point 2, 2 in the shaded region? No, it is not. So no. The point 2, 2, since it is not in the shaded region, is not a solution. So no, it is not in the shaded region, therefore it is not a solution to that system of inequalities. one more thing. So, what if I ask about, what about the point negative 7, 8? Is that a solution to the system of inequalities? So let's find where this point is. So we're going over negative 7 to the left, up 8. So it looks like our point would be right there. So it'd be the point negative 7, 8. So we can see that this point is inside the shaded region. So yes, that point is a solution. Alright, so let's go ahead and flip it over. Let's do another example. Okay. So here we can see we have y is less than negative 2. Since we have less than, the first thing we can see is that this is going to be a dashed line. And we can also see that it is going to be a horizontal line at x equals negative 2. So if we have, or y equals negative 2. So if we have y equals negative 2, our point is going to be 0, negative 2. And our line is dashed, and the whole thing is at y equals negative 2. So there's our horizontal dashed line. And let's go ahead and pick a test point. I'm going to pick 0, 0, so it's easy. So there's our test point. Okay, so we have y is less than negative 2. We know y in our test point is 0, so we have 0 is less than negative 2. And that is false. So since that is false, we are going to shade everything on the other side of that test point. So we are going to shade everything below this horizontal line. So I put my arrows on showing me which side I'm going to shade. And now we have to work on the other equation, which is a little more difficult. Okay, so the first thing we see, we have less than or equal to. So that is going to be a solid line. Okay, so we had this negative out front, which first thing you should have noticed, we have absolute value bars. So instead of a line, we're going to get our V-shaped graph. So if you want to put a little note out to the side, this is an absolute value graph. Okay, so this negative out front, that is a reflection of the x-axis. This 2 out front, since it's greater than 1, it is a vertical stretch of 2. And so we have plus 3 on the inside, which we are going to do opposite of what we normally would do. So instead of going right 3, we're actually going left 3. And the plus 1 on the outside tells us we are going up 1. Okay, so we have a lot going on here. So off to the side, let's go ahead and find our vertex. If we are going left 3, left and right affects our x. If we are going left, we're going to have negative 3. And we are going up 1. So our vertex is at negative 3, 1. So let's go ahead and plot that point. So negative 3, 1 is right here. Okay. So let's figure out how to graph this. Go over 1, up 1, over 2, up 2, over 3, up 3. Okay, so we are actually going over 1, over 2, over 3, but instead of going up 1, we have a vertical stretch of 2, and we are reflecting over the x-axis. So we are multiplying our ups by negative 2. 1 times negative 2 is negative 2. 2 times negative 2 is negative 4. 3 times negative 2 is negative 6. So, I know a lot of you guys like to write, we're going over 1, down 2, over 2, down 4, over 3, down 6. That is the same thing if we're going up negative 6, we're really going down 6. So let's go ahead and plot this. So we're going over 1, down 2, back to the vertex, over 2, down 4, back to the vertex, over 3, down 6. And then you're doing the same thing on the other side. Over 1, down 2, over 2, down 4, over 3, down 6. Okay. So, we said this is a solid line. Okay, so let's go ahead and pick our test point. Let's go ahead and test negative 6, 2. So there's our test point, negative 6, 2. Okay, so we have y is less than or equal to. Our y is 2, so we have 2 is less than or equal to. We have negative 2 times the absolute value of x plus 3. Our x is negative 6 plus 3. We still have plus 1. So on the left side, we still have 2 is less than or equal to. Negative 2 times absolute value. Negative 6 plus 3. Negative 3 plus 1. So we have 2 is less than or equal to negative 2. The absolute value of negative 3 is 3, so we have negative 2 times 3 plus 1. So we have 2 is less than or equal to negative 2 times 3 is negative 6 plus 1. So last step, 2 is less than or equal to negative 6 plus 1 is negative 5. Is 2 less than or equal to negative 5? No, it is not, so that is false. So since it's false, we are shading everything on the side that our test point is not on. So over here, our test point is on the outside of our absolute value graph. So we are actually going to shade everything on the inside of our absolute value graph. Okay, so now it is time to go ahead and shade our overlapping region. So our line at y equals negative 2 is everything below, but the absolute value graph is everything on the inside. So we're going to shade everything below our line and inside the absolute value. Okay. So we are not shading this piece right here because this is above our line at y equals negative 2. So this is our overlapping region of that system of inequalities. Okay, last example. Okay, so it says a college entrance exam has 2 sections, math and the verbal. It says you can score a maximum of 1,600 total points. So we can score a maximum of 1,600 total points. For admission, your school requires at least 700 points on the math section and at least 1,200 points overall. So, it says that your school requires at least 700 points on the math section. And it also tells us that the school requires at least 1,200 points overall. So it says we need to write and graph a system of inequalities to model scores that meet the school's requirements. Okay, So let's go ahead and assign our variables. So let's make our y our verbal score. And let's make our x our math score. Okay, so we are going to have to draw a little graph over here. Okay, this is our y, this is our x, and we said the y was the verbal score, and we said our x was our math score. Okay, so we know we're starting at 0. We know that the maximum total points is 1,600. So up here we're going to have 1,600, and our max over here is 1,600. And on the bottom, let's go ahead and go by 200. Okay, and let's go ahead and go by 200 on the side as well. That wasn't very good. I'm going to move this one down. Okay, so let's go ahead and write our system of equations, or our system of inequalities. So, the first one, it says that we can score a maximum of 1,600 total points. So if we have a maximum of 1,600 total points, that is our verbal score and our math score combined. So that's going to be our math score plus our verbal score. And if the maximum is 1,600, we are either going to be less than or equal to that. We're going to be less than because we can't go over 1,600, but you can be equal to because if this is the max score, someone can go ahead and score the max score. So we have x plus y is less than or equal to 1,600. That is our first system of inequality. The second one, we said that our school requires at least 700 points on the math section. So if we have to have at least 700 points, so we have our math section, so the math score. If it's at least 700, we're going to have to be greater than or equal to 700. Okay, so we have 2, and we are going to have a third system of inequality. Our third one, it says that your school is going to require a 1,200 overall score. So if we have a 1,200 overall score, that is going to be our math, our math plus our verbal. And if we have at least, we can be greater than or equal to that. So we have x plus y is greater than or equal to 1,200. So these are our system of inequalities. And those are the 3 we're going to work with. Okay. So let's look at this one first. Let me get a different color. So let's look at x plus y is less than or equal to 1,600. So we know this is a line. It is in standard form, so we're going to do the cover-up method. So if we cover up our y, we can see that x equals 1,600. So if x equals 1,600, our point is at 1,600, 0. And let's find our y. If we cover up the x, our y is also going to equal 1,600. So if y equals 1,600, our point would be 0, 1,600. And right here, we can see that we have a solid line. So let's go ahead and plot this line. So if we have 1,600, 0, so that means we're going 1,600 in the x direction. We are going up or down 0. So 1,600, 0. Okay, let's plot the y. So we have 0, 1600. So if we have 0 first, we're going left to right, 0, but we are going up 1600. So there are 2 points, and we are going to connect them. Okay, so there's the first one, and let's go ahead and pick our test point. And I'm going to pick 0, 0. And let's see if it's true or false. So we have x plus y. Our x is 0 and our y is 0. So we have 0 plus 0 is less than or equal to 1600. Is 0 less than or equal to 1600? Yes, it is. So that is true. So since it is true, we are going to shade everything that is on the side of our test point. So that is everything on this side of this line, because our test point is right here. Okay? So let's go ahead and plot the second one. This also tells us we have a solid line. And this is also a vertical line. So we have a vertical line at 700. So x equals 700. So 700 is right here. And we are going to make our vertical line, which goes up and down, at x equals 700. Okay, so there's our line. And we get to pick a test point. And I'm going to pick 0, 0 again, just to make it easy. So we have x is greater than or equal to 700. Our x is 0, so we have 0 is greater than or equal to 700. Is that true or false? It is false. 0 is not greater than or equal to 700. So since it is false, we're going to shade everything to the right of that line, because our test point is to the left of that line. So we are shading away from that line, or from that point. Okay, so last one. We know this is solid. We also know it is a line. And this is in standard form as well. So let's cover up our y first. So we have x equals 1200. So if x equals 1200, our point is going to be at 1200, 0. Now we have to find our y. So we're going to cover up the x. So we have x equals 1200. Or y equals 1200. If y equals 1200, our point is 0, 1200. Okay, so let's go ahead and plot both of these points. So 1200, 0. So 1200 is in our x, so we're going left or right, but it's positive, so we're going right 1200, and we're going up or down 0. So there's our point. So we have 0, 1200. We're going left or right 0, but we are going up 1200. So there's our 2 points, and we have to connect those. So there's my solid line. Okay, so now we have to pick a test point. And I'm going to pick 0, 0 again. We have to plug it in. So we have x plus y is greater than or equal to 1200. Our x is 0, and our y is 0. So we have 0 plus 0 is greater than or equal to 1200. So we have 0 is greater than or equal to 1200. Is that true or false? Hopefully you know that is false. 0 is not greater than 1200. So if our test point is over here and it's false, we're going to shade on the opposite side. So we are shading everything on this side. Okay, so now that we have all 3 inequalities plotted, we're going to shade the overlapping region. So our vertical line, we're shading everything to the right, but we're shading below this line and above this line. So our overlapping region would be this piece right here. So there's the overlapping region of all three of those system of inequalities. Okay, so the last question it asks us. Would you be admitted if you score 720 on math and 400 on verbal? So let's go ahead and find out where this point is. If we have 720 on math, our math scores is the x, so we're going over 720, so about right here. And verbal is the y, so we're going up 400. So if this is the point, 720, 400, would we be admitted? No, we would not. And that is because it is not in the shaded region. So the solutions to this system of inequalities is everything that is in this overlapping shaded region. And our point right here was not, so it is not a solution. Therefore, you would not be admitted.